Hello everyone, can you all hear me? Yeah, thank you. I'm Yasmin, I'm a software developer at IBM. I'm also a Eclipse committer specifically for MicroProfile. And I'll be teaching you today how to look at your applications like clinical physicians, how to debug and think like a clinical physician using metrics and tracing. So does anyone here use microservices when developing? Yeah, most of you. Great. And so I'm sure you're really aware of the advantages of microservices. They are really great for things like scaling, so you can scale parts of your application that require more resources than others. It's really good for effective migration and updates, so you can update certain parts of your application or system without having to affect other parts, which is also good for maintainability, so you can also educate your team and make them really specialize in certain parts of your application instead of others. And you can have effective automation of tests and deployment. So they are really great. But like most things in life, they do come with problems. So here you've got a system where you've got the user in the bottom left, and they're only interacting with service A, which is really good practice, probably the front-end service. A is communicating with service B. Service B has a few incomings and outgoings there. Yeah, sorry. Sorry, hopefully that's better. So service B is communicating with multiple services, and then you've got C, D, and E, which are other back-end services. We're not really focused on what they do, but it's just an idea that you've got different services communicating in different ways. So if we do have a problem, such as inaccuracy or latency coming from service A, it's really unclear in this situation how to tell which service is causing the issue. So it's difficult to see how these services depend on each other or affect each other, and therefore the source of the latency or inaccuracy. This often results in a headache. And you may remember me saying at the start, we're going to be thinking about these problems like clinical physicians here. And although we've got a symptom, which is inaccuracy or latency, we don't know the cause of that, and therefore we don't know how to treat it, and therefore get rid of the headache. When I have a headache, personally, I don't usually go to my doctor. I do what most people do, and I Google it. And when I did Google a headache, I got this long list of possible causes from the NHS website. So it could have been a cold or flu, stress, drinking too much alcohol, bad posture, long list of things here. And not quite sure which one unless I go through the massive list and then figure it out what was causing my symptoms and then deal with it that way. The NHS also told me, keep a headache diary to help work out what triggers your headaches. And when I thought about this, I realized this is basically saying, observe what's going on in your body, what's happening for it, and therefore what's causing your symptoms. So how do we observe our applications when we're getting symptoms like inaccuracy and latency, and therefore find the cause and get rid of it? I did find the cause of my headache, by the way, and it was my microservice architecture. So that was great. So after doing some research of what observability actually is, I've got quite a neat definition here which kind of brings everything together. So observability is software tools and practices for aggregating, correlating, and analyzing a steady stream of performance data from a distributed application. This will allow you to monitor, troubleshoot, and debug all of your application and networks. So what that basically means is keeping track of your application from the moment a request is sent to your application all the way through to when a response is given. When you've got this information, you can then monitor it, troubleshoot it, and find problems and debug. So how can we do this in our distributed applications? If you've got a monolith application, you just go through your logs. The request is made in one application, everything's always together. But when you've got a distributed system, you're going to want to use these three pillars, which are traces, metrics, and logs. I'm sure you're very familiar with logs already, maybe not so much with traces or metrics, so I'm going to be diving into them today. So the first concept I'm going to introduce to you is a trace. So this is a path of request through your application from the moment the user interacts with your system all the way to their response. And there's another term here that I'm going to use, which is a span. And a span is a single operation in a trace. You've got this diagram here, which is over a period of time. This could be 3 seconds, for instance. And you've got one whole trace. This consists of 5 spans. Each of my services have given a different span. You've got service A, which is the front end, communicating from the start of the user all the way to the end. Service A communicates with service B, which communicates with service C and D consecutively. And lastly, service A communicates with service E. It's just a representation of all of those communications throughout the application. It's good to visualize. Next of all, we have metrics, which is another way of observing your application. This can be a range of different pieces of data. For instance, I've got a little list here, but the list really does go on. You've got the JVM memory used, the number of threads in your JVM, classes loaded, CPU time used by a process. These are all runtime metrics collected at the runtime level. You've then got a number of HTTP requests that you're going through each over a certain amount of time, like an hour, a minute, however long you want to observe, and the duration of a HTTP request. If you see differences in this or spikes, then you'll probably know something's going a bit wrong in one of your services or your application, and then you can dive into why. And lastly, I'm sure you're very familiar with logs. Sorry if you're not, but I'll let you know if you are. So a log is a record of information, and it's used to keep track of what exactly is going on in your application and identifies events that could signal a problem. So you can have logs of what each part of your application is doing. So I'm going to introduce a project here called Open Telemetry. Has anyone heard of it before? Yeah, everyone seems quite familiar. So Open Telemetry was a project joined by Open Census and Open Tracing. And it really humbly describes itself as a high-quality, ubiquitous, and portable telemetry to enable effective observability. And what it is to developers is a big collection of tools, APIs, and SDKs that they can use for their application in order to collect, generate, and instrument all of the telemetry data I was mentioning before, like traces, metrics, and logs. And as a result, you can analyze your software's performance and behavior from the runtime all the way to the interaction with the front end. So at a really low level here, you've got the different concepts in Open Telemetry. As I said before, it's a project merged from Open Census and Open Tracing, which you may have used previously. And it consists of these components. You've got the Open Telemetry API. This has a range of stable APIs to make a tracer, a span. The meter is what you use to create metrics, and you've got baggage and context in order to transfer information between services. You've got semantic conventions, and these are common names that you use throughout observability, throughout those pillars, to keep consistency when you're labeling things throughout your application. There are some extensions for the API, which aren't part of the core API, but there's a big long range of different libraries you can take from OpenTelemetry. The SDK is what you can use in order to build your implementation of the API, and also contains different extensions like before. If you've previously had Open Tracing shim or the Open Census, then you can use the shim in order to bridge a layer between your existing observability over to OpenTelemetry's new features, APIs, and export them in an OpenTelemetry way. So how do we actually instrument this and use it? So OpenTelemetry has 2 big components here. You've got the Java agent instrumentation, which is really automatic. It's not too configurable, but you just attach it straight onto your JVM, and it will run as a sidecar collecting telemetry data for you, and then you can export data. Or you can really use manual instrumentation of the OpenTelemetry API and inject and implement things straight into your code using the OpenTelemetry API, so using OpenTelemetry, tracer, span, meter, the APIs I mentioned before. So I'm going to introduce MicroProfile Telemetry 2. Has anyone heard of MicroProfile before? Reading my t-shirt doesn't count, but yeah, great. So brief introduction then. MicroProfile is a specification for runtimes. I contribute to MicroProfile, and I'm a backend developer for OpenLiberty, which is a Java runtime implementation, and it uses MicroProfile specifications in its features. So one MicroProfile specification we've been working on this past couple of years is MicroProfile Telemetry. And what it's done is it's made a specification for runtimes to adopt OpenTelemetry in a standard way. And it would outline the metrics, logs, and traces that are required in order for developers to observe their microservices really effectively. So we've said what traces should be available, how they should be able to inject different APIs and use those and get automatic observability data throughout their applications. So similarly to what I mentioned before, MicroProfile Telemetry supports tracing, metrics, and logs. With the tracing, it will support manual instrumentation, so it will allow users to inject and instrument their code with the OpenTelemetry API. And we also provide automatic tracing. So this would mean any Jakarta RESTful web services that you've got or MicroProfile REST client requests are automatically traced without you having to touch your code. You just enable a feature or the implementation of the specification and you get those automatic traces. Next of all is support for metrics. So similarly to tracing, you've got manually created metrics with the OpenTelemetry API. So this would mean that you collect metrics throughout your application. Maybe you want to see how many requests a certain method in your class had, or specific services could have more metrics than others. You've got JVM memory metrics, which again from the runtime, but these are automatically collected. Same with HTTP server metrics. So any HTTP requests that your servers are making, those will be collected with automatic metrics. And lastly, it's a bit different with logs. I'm sure a lot of you have your log system already established on your application. You've probably been collecting logs from the moment you started building. So OpenTelemetry instead provides a bridge with your existing log framework so you can export it in the same way as your metrics and traces without you having to do much. It just provides a bridge in the API. So you've got OpenTelemetry collecting your data for you, instrumenting and picking what specific things to send, but where does it send it to? So you're going to need a backend exporter. And you can export all the data that MicroProfile Telemetry collects to multiple exporters. You've got Jaeger and Zipkin there for tracing, Prometheus and Grafana for metrics. You've also got other parts of Grafana like Grafana Loki. And the OpenTelemetry collector is one backend exporter which collects all of your telemetry data and will export it and distribute it in ways that you want, maybe through filters, different configuration in order to minimize what you export to its backend like Grafana, Prometheus, that kind of thing. Specifically with OpenLiberty here, I've got an example of a use case. So in the top left-hand corner, you've got one host hosting an application on OpenLiberty. Some metrics, logs, and traces would be collected, and you can just have these out to your console. You can put them straight into your standard output. Or you can send your metrics and logs to the OpenTelemetry collector and get that to export them to a backend service such as Prometheus and Grafana or Loki and Grafana, and you can view them from there on a nice dashboard. You can send your traces either directly from the host or through the OpenTelemetry collector to Zipkin, Jaeger, Tempo, and Grafana, and you'll be able to view them there. So I'm going to do a demo. Please bear with me, you know how demos can go in presentations. And the demo is going to consist of a few services here. You've got the system service. It's really simple. When I go to the endpoint, it's just going to give my system properties. My next service is the inventory service, and that's going to call my system service. You've got service A and service B communicating with each other, and I'm only going to be really communicating with my inventory in this situation. This will retrieve the system property information from service B. If my system is new and I haven't seen that endpoint before, it's going to add my host to an inventory and store it. There's another endpoint in the inventory service, and it will be able to view all the systems in the inventory that I've previously added. Just a really silly demo application there. And then while all of this is going on, I'm collecting metrics, traces, and logs in my application. And what I'm doing for this specific demo is sending everything to a Docker container running Grafana, OTel, LGTM, which I think is a really good name. Not best practice for production, but just for demo purposes, inside of my container, I'm running quite a few different backend exporters here. All of my data is first going to go to the OpenTelemetry collector, and then my data is then going to either go to a Prometheus metrics database, a tempo trace database, or the low-key logs database. And I'm going to view all of this different information in Grafana and see what's going on in my application through my web UI. So let's get going. 1 second. Can you all see that? Hopefully, yeah. Okay, so these are two different services running on OpenLiberty. I've got the system service, which, as I mentioned before, is just returning my system properties, just this really small method here. As you can see, I've got absolutely no code in here for OpenTelemetry. I've got this import, which I don't need, actually. And my system application, as well, doesn't have any OpenTelemetry code. In my server XML, I've just enabled the telemetry feature. I've also got an MP telemetry source, which means I want all of my log messages to go to OpenTelemetry. I'm enabling OpenTelemetry by enabling the SDK in my config, and I'm creating a service name for it to send to OpenTelemetry called system. I'm just going to send it to the default endpoint, which is localhost 4317. So I won't need to do any extra configuration, but any configuration I want to do about where to send my data to, I'll do it in my configuration. Notice as well, I've put this in my server.end, so these are my environment variables. So that means I'll be able to trace from a runtime level with my JVM options and things like that. And I'm just going to check this service now. If I go to system properties, that is running, and it's just my system properties, not much of a exciting service. Next of all, I'm going to go through my inventory service. Now, this is a little bit different because I've actually used the OpenTelemetry API to generate manual traces. So, as you can see here, I've got the inventory manager. So every time you add a new system to my inventory, I want to add a span. So I've annotated my method with the with span annotation. That's all I've done for this class. When I go to my inventory resource, I'm going to manually create spans. So when the properties are gathered from the host, I'm going to create a span manually here. I haven't just annotated it with span because I wanted to call it with a separate name. You could add events here to say that I've received the property. So you can have one span for one method, but add single events. So every time something happens in that method or that service, you've got specific small parts. And then I've just got the endpoint there. Similarly to the other service, on my server XML, I've got the MP telemetry feature enabled, and I've got the minimum config I need for OpenLiberty in order to generate some metrics and tracing here. And I've just enabled the SDK and enabled the set the service name to inventory. Just to show you that I'm going to add a new system, I'm going to shut down the inventory service that I've already got running and start it up again. Okay, so my server's started, and hopefully demos, hey. There we go, application took a while. Okay, so first of all, it's showing no systems in my inventory. So what I'm going to do is add my system in by calling this endpoint, which is inventory systems, and then give it my host, which is localhost. It just communicated with the systems endpoint and returned my properties. Now when I go into my localhost inventory systems, my system is there and you can see it. So a few things went on behind the scenes just for me to see my system properties. Obviously in a real world, you would have many more services than this with many more methods, many more classes, a lot more going on. I'll show you my Grafana dashboard. So I started this the service is up about, I think it was about 10:30. So this has been running for about an hour with some intervals of when my laptop was shut down. But it's tracking both of my OpenTelemetry servers. You've got the duration, the heap memory, number of classes, number of threads, that kind of thing. So when I reloaded my inventory service, you can see here a spike. And when I go to, so this is obviously metrics collected automatically with no extra configuration on the runtime. I'm going to go here and also check the logs, which is another pillar of OpenTelemetry. So this is what was collected through Loki. And I'm going to go on service name and filter through. I can check my inventory, but I'm just going to check system. What I did here was, in my system service, I put in a really simple, silly log, which was to JUL getting system properties. And I put it at an info level. When I run the query, you'll see here are spikes of when I've gone to that endpoint throughout my morning. And that's how many logs have been generated. So maybe if you saw a spike of so many logs, you know a lot of events were happening. If you've got nothing, it means no users have really been interacting with your system. So this is what was done when I communicated a minute ago. You can see at 11:46 there were some logs. And it's just get system properties, knowing that that event was hit and it was hit as expected. If I hit the endpoint a few more times, hopefully it will automatically update really fast. There's another little spike there from when I just hit the endpoint at 11:47 and it hit so many times. So there's another spike in logs. And the next thing I'm going to show you, which is the exciting part for me, is the traces. So this was exported obviously to the OpenTelemetry collector like the other endpoints were, and then sent over to Tempo and Grafana. So you can see here a list of traces and spans. And the service I'm really focusing on here is the inventory service, because that called the system service as well. So it's going to show spans for the inventory service and spans for the system service. So that's what I hit 2 minutes ago at 11:45. And the one before that has more spans in it. So I'm going to check this one. And you can see here, similar to the diagram I showed in the presentation at the start, you've got one single trace with multiple spans. You've got this, which is the whole request at the top. Then it called the inventory class. This tiny one here, the blue one, is actually from the system service. You can see there at the bottom, I've got system get properties. And this is the manually created span that I had when I annotated my method with the with span annotation over here. When I added a new host to my inventory. So every time a user communicates with your system, you'll be able to see timestamps exactly of when each part of the request and response happened and what exactly the process they went through. If there was an inaccuracy, for instance, they didn't get the system properties, or it was wrong, or it returned an error, you'll be able to see the exact set point of what went wrong and where it got that information from. Another thing which I think is quite cool is the node graph. So this is the graph of my process, and from the request to the response. First of all, I communicated with the inventory systems and then gave the host name. It did two things from then. It got my system properties, and you can tell it did that quite quickly. The first GET request was a bit slow, but the slowest part of that whole process was getting the properties for the host and adding my host to the inventory. Just that tiny method was really quick. It was only 0.05 milliseconds, but adding it to the inventory and that whole process took the longest part of my request. So it shows what to focus on if they are coming across latency and inaccuracies. The next thing to show is HTTP server requests. So again, this is an automatically generated metric. I did no instrumentation in my code for generating metrics. This is just what OpenTelemetry, when given the MP telemetry feature, is generating. So as you can see here at 11:15, just before my presentation, I hit my endpoint so many times just sitting at the back. And you can see here the request duration shut my laptop down for a bit so my servers weren't running, and then communicated a bit here. And you can see here the responses throughout my HTTP requests have been really consistent. I can also show sorry, one sec. Okay, so here is a dashboard with all my different metrics. I think this one's quite good to see different peaks. So here was when you see garbage collection duration, this was when I gave it the heaviest load. If you have different spikes, obviously you can see there's something wrong with your application, or maybe getting too much traffic. You maybe need to scale up, scale down, that kind of thing based on these metrics. It's just quite cool to look at, really. So this is obviously only with 2 different services running, A and B, but if you had maybe 10 services running in your node pool, it would just be better to see what service is doing what with what request. So that's all I have from the demo. Do I have any questions? I've got another like 5 minutes. Nothing at all? No? All right, well, thank you. Oh yeah, one at the front, perfect.
So, I'm wondering how you how many traces or how many scans you collect. Because the large application and the large ecosystem, there can be millions of scans.
Yeah. Good point. So that's what's really good about the OpenTelemetry collector, because its job is to collect all of your information, or however much you send, and then only export to the back end what you want. So you can filter through service name. You can collect a batch of traces and then only send a batch. You can maybe send only 100 over a course of an hour, or you can collect, you can only send traces that were for a duration of time, or only ones that hit certain classes. You can really filter. When I had my configuration here, you can, if you go on this, oh, sorry, it's not sharing. When I configured my application with enabling the SDK and giving it a service name, there's so many more different properties that you can do in order to configure OpenTelemetry. So I'll provide you with a link after with a full list, but it's really configurable. So it would only send over what you specify to send over. Right now I've got the absolute basic, so it's sending everything.
So that is only when you're using the OpenTelemetry backend. If you're using a Jaeger backend or Jaeger collector, like the other, you don't have this option to...
Yeah, with Jaeger, well, so if you're creating traces with OpenTelemetry and then sending directly to Jaeger, and you're configuring that endpoint to go to Jaeger, you can also with Jaeger configure batches. Okay. I'm pretty sure, well, at the moment, you would have to configure it with OTLP. Do you use the OTLP protocol or just straight up Jaeger? Yeah, so previously, you would be able to send traces straight with the Jaeger protocol, like gRPC or HTTP, from your application. But the Jaeger tracing's being not deprecated, but the protocols that it's sending are deprecated now, and it's relying mainly on OpenTelemetry to receive its data, and you'd use the OpenTelemetry one. But there's definitely legacy Jaeger tracing configuration that you can use. No worries. Anything else? No? All right, well, thank you, everyone. I will be around if you've got more questions today and tomorrow, but it was great speaking to you all. Thank you.